From our experiment, we calculated a 3.3% difference in proportions of free throw scored with distractions and free throw scored without distractions. We concluded that we performed 3.3% better without distractions. But how can we be sure that we performed 3.3% better without distractions because distractions affect our free throw performance? How do we know that this didn't happen in our experiment just by chance? To answer these questions, we can use a simulation. We can take our raw data from our experiment, randomize it, calculate the simulated differences in proportions, and keep track of how often we are able to generate our class difference in proportions from the experiment, this 3.3%, or differences in proportions that are even more extreme just by chance. In other words, we are finding out how easy or difficult it is to get our class difference in proportions from our experiment, or differences in proportions that are more extreme, by chance through the random simulation. To begin the simulation, we must first assume that distractions have no effect on free throw performance. How likely is it that we performed 3.3% better without distractions in our experiment just by chance? To prepare for the simulation, we have to cut apart our raw data so that we can literally rearrange and randomize it. Here, you can see me cutting up each group's data and placing it into a labeled envelope. When my 7th graders were working through this unit, I had each group cut apart their own data. It did take up a little bit of class time, but I felt it was very important for them to understand that the data we were randomizing in the simulation was actually their raw data from the experiment. Here's where we actually begin the simulation. We are starting with Group A's data. Here, you can see me randomly arranging the data into an organizer that has the same table labels as on the raw data sheet. After I finished randomizing the data, I counted up the results and summarized them in a spreadsheet. These are the results for Group A for Trial 1. The whole class table on the right is compiling the results for all groups so far in Trial 1. We repeat this randomization process with Group B's data. Again, I count up the results and put them in the spreadsheet. Notice that the whole class table on the right is adjusting as I enter the results for Group B. Now we're on to Group C. This is still part of the first trial. Again, I randomize the data. I count up the results, and I put them into the spreadsheet. Here's Group D. I repeat the process again. Randomize the data, count up the results, and you'll see me fill in the spreadsheet. This is Group E. Here I'm randomizing. I'll count up the results, and then again, put them in the spreadsheet. Group F is the last group. Randomize the data, count up the results, put it in the spreadsheet. Now we are done with trial 1. We're going to take the compiled whole class data from this table and copy it into our packet on page 9 in the table for trial 1. Here I'm calculating the simulated difference in proportions from trial 1, which is about 6.67%. I suggest you follow along and copy this into your own packet so you can experience at least part of the simulation process. Remember, our class difference in proportions from the experiment was about 3.3%. I marked this on the dot plot with a vertical pink segment. Now I'm marking the 6.67% difference in proportions that we just simulated in trial 1. You should mark this in your packet too. Now on to trial 2. I repeated that entire process with all 6 groups, randomizing the raw data and counting up each group's results. I skipped showing myself rearranging the paper pieces on camera, but here you can see me entering the results for each group for trial 2. Again, I am going to take the whole class compiled data from this table and copy it into the packet for trial 2. The simulated difference in proportions for trial 2 is 10%. Here, I'm plotting 10% on the dot plot to represent the simulated difference in proportions from trial 2. I repeated the raw data randomization process for each of the groups again for trial 3. I have counted up the results for each group, and I'm entering them into the spreadsheet here. Again, I'm going to take the compiled data from trial 3 and copy it into the packet. The simulated difference in proportions from trial 3 is about negative 6.7%. I'm adding negative 6.7% to our dot plot. Here's trial 4. I have already entered the results for each group in the spreadsheet. I'm taking the compiled whole class simulation data and copying it into the packet. The simulated difference in proportions for trial 4 is 10%, which is the same difference in proportions we simulated in trial 2. I'm placing another point at 10% on our dot plot to represent the simulated difference in proportions from trial 4. Here is the completed spreadsheet for trial 5. Here's the compiled simulation data. These numbers should look very familiar. These are the numbers that we actually came up with during our experiment. We were able to randomly reproduce the exact results of our experiment. I have already copied the table into the packet for trial 5. Now I'm calculating the difference in proportions, which we already know is about 3.3% because it's the same as in our experiment. Now I'm plotting the 3.3% on the dot plot. It will fall exactly on the pink vertical segment because it matches the difference in proportions we got in our experiment. One last time through the entire process for trial 6. Here are the results for each group already in the spreadsheet. I have already copied into the packet and calculated the simulated difference in proportions, which is about negative 13%. Now I'm plotting the negative 13% on the dot plot to finish off trial 6. Let's take a look at these prompts together. How often did the difference in proportions of free throws scored with distractions and free throws scored without distractions that we found in our compiled whole class data summary occur during our simulation. So just a reminder, our whole class difference in proportions from the experiment was about 3.3%. And that's represented here with this pink horizontal segment. So we actually simulated our exact class difference in proportions from the experiment once out of the 6 trials. And that's represented with this dot here on 3.3%. So another way to think about this idea is that our difference in proportions was randomly generated in 1/6 of the trials, or in about 17% of the trials. Our exact difference in proportions from the experiment showed up just by chance in our simulation 17% of the time, which is a lot. It seems easy to simulate our difference in proportions just by chance. Did we simulate any differences in proportions that are more extreme than our class difference in proportions? How does this compare to the number of trials we did during the simulation? So this phrase, more extreme, really means having the same conclusion, but even stronger evidence. So with a difference in proportions of 3.3%, we could conclude that we performed better without distractions. A difference in proportions of 10%, represented with these 2 dots that we simulated, we would also conclude that we performed better without distractions, but performing 10% better is much better than performing 3.3% better. So a difference in proportions of 10% would be considered more extreme than our difference in proportions of 3.3%. And anything to the right of 3.3% would also be considered more extreme. All of these differences in proportions, we would conclude that we performed better without distractions, but all of these differences in proportions are much better than a difference of 3.3%. If we had a difference in proportions of 2%, which would be slightly to the left of 3.3%, we would still have the same conclusion that we did better without distractions, but 2% better is not much better than 3.3% better. So a difference in proportions of 2% would not be considered more extreme than 3.3%. A difference in proportions of negative 13%, like this dot down here that we simulated, would not be considered more extreme than 3.3% because it has the opposite conclusion. A difference in proportions of negative 13%, we would conclude that we perform better with the distractions. So we simulated 3 differences in proportions out of our 6 trials that were more extreme than our class difference in proportions from the experiment. And those are represented by these 3 dots that are to the right of 3.3%. So differences in proportions that are more extreme than ours were randomly generated in 3 of the 6 trials, or in half of the trials. More extreme differences in proportions showed up by chance 50% of the time, which is a lot. In other words, it seems very easy to simulate differences in proportions that are more extreme than ours just by chance. If we take these 2 ideas together, we can say that we simulated our difference in proportions from our class experiment, or differences in proportions that were more extreme, in 4 out of the 6 trials, which is about 67% of the trials. So our difference in proportions and differences in proportions that are more extreme showed up by chance 67% of the time, which is also a lot. It seems very, very easy to simulate our difference in proportions or differences in proportions that are more extreme just by chance. So here's something to think about. If it is super easy to simulate the difference in proportions from our experiment, or a difference in proportions that is more extreme, just by chance, then what does that mean about how we got the difference in proportions in our experiment? In our experiment, did we perform 3.3% better without distractions because distractions affect our free throw performance? Or in our experiment, did we perform 3.3% better without distractions just by chance?